In the 2009 higher level paper for question 1, we can see that our titration question is the iron tablet titration. Now what we're going to do to begin is to identify which quantities belong to which chemical. Now in the information I've given, I've included part C. We're not actually going to answer part C, it's a procedural question on making up a solution. But the reason I included it here is because it gives us the mass of each iron tablet. So it's telling us how much each iron tablet weighs. So it's the Fe2 plus, because we're going to need that later. If we go on to part E, we're told 18.75 mils of a 0.1 molar potassium permanganate solution. So the 18.75 mils, the 0.1 molar, belongs to the permanganate. And that was required to react with 25 mil portions of the iron solution. So the 25 mils there belongs with the iron. So now that we have all of the quantities mentioned, that 250 belongs to the iron as well. That's how much solution we made up in the beginning. Now that they're all labelled, we can get on to the actual calculations themselves. So if we look at E part 1, we're asked to calculate the molarity of the Fe2 plus solution. So to find the molarity of the iron solution, we first need to start with the molarity that we know. So the concentration we know, which is 0.01 moles per litre of the permanganate. But we didn't use a litre of the permanganate, we only used 18.75 mils. So to find how many moles are in 18.75 mils, I'm going to divide by 1000 and multiply by 18.75. And that gives 1.875 times 10 to the minus 4 moles in 18.75 mils of the permanganate. So that's how much permanganate it took to oxidize all of the iron. So to find out how many moles of iron were oxidized, I need to use my ratio. So I need to get a ratio between permanganate and iron 2 plus. And that comes from the balanced equation. So from the balanced equation we can see that for every 5 Fe2 pluses, we needed 1 permanganate. So for every 1 permanganate, 5 irons. So I know if I had 1.875 by 10 to the minus 4 moles of permanganate, I had 5 times as many moles of iron. So we're going to multiply it by 5. And that means there were 9.375 times 10 to the minus 4 moles of Fe2 plus in our solution. So there were 9.375 times 10 to the minus 4 moles in, how much iron solution did we use each time? 25 mils. So that's how many moles there are in 25 centimetres cubed of the iron 2 plus. But the question wanted molarity, and molarity is moles per litre. So to convert that into moles per litre, I need to take my number here of moles, divide it by 25 and multiply it by 1000. And that gets 0.0375 moles per litre of the Fe2 plus solution. That's part 1 finished. Part 2 then says the total mass of iron in the 250 mils of solution. So that's really a disguised way of asking for grams in 250 mils of iron. So I need to convert my previous answer, my moles in a litre, into grams in 250 mils. So for part 2, I need to go from moles per litre to grams in 250 mils. So I'll go from moles to grams first. And to go from moles to grams, I need to multiply by the molecular mass of iron, which is 56. So I'm just going to take my 0.0375 and multiply it by 56. And that gives 2.1 grams per litre of iron. Now the 2 plus doesn't, we don't have the 2 plus there now anymore, it's just iron. But we need grams in 250 mils, so I'm going to divide by 4, because it's a quarter of a litre. And that will give, 0.525 grams in 250 mils of iron. And that's part 2 finished. Part 3 then says the percentage by mass of iron in the tablets. So I need to find out I need to find out the mass of iron in each tablet. Now when we made up this solution, or when the person who did this experiment made up the solution, they dissolved a certain number of tablets in 250 mils of solution. And if we go up in the question, we can see that that solution was prepared from 5 tablets. So if that's the total mass of iron in the 5 tablets, to find the mass of iron in 1 tablet, I just need to divide that by 5. So if I divide that by 5, that gives me 0.105 grams of iron per tablet. So that's how many grams of iron there were in each tablet. Now to get the percentage of iron in the tablets, what I need is the mass of iron in a tablet over the mass of a tablet, and then multiply that by 100 over 1 as a percentage. So the mass of iron in each tablet was 0.105. The mass of each tablet from our question is 0.325 grams. So put that over 0.325 grams and multiply by 100 over 1. And that gives, 32.3%. So that's the percentage of iron in an iron tablet, which is what the question asked for. So that's those calculations finished.